Hey guys, welcome back to Quadratic Equations and Functions Revision. Here we consider and keep doing problem solving. So we've done the first two problems. The second one was pretty outstanding in terms of complexity, but anyway it was based on first set up quadratic equations by finding out that two triangles are actually similar and using proportions in order to complete first quadratic equations, and then we solve that using quadratic formula. All right, so using discriminant, and that's how we find out solutions. So we move next. Here is the next step. Here we need to find value for x. So we're given two sides of the triangle. So for the small one and for the big one, they are parallel. So that's what those arrows means. Okay, so if their sides are parallel, apparently we have two similar triangles. So we can state that if we start considering triangle, the big one VZW is similar to the triangle A1, B1, and Z, the small one. Why? Because apparently we have Z as the common angle. Next one, we have A1 and V are also the same because two parallel lines and the second line that arrange two identical angles, and also B1 and W for the same reasons. So two parallel lines and the second line, let's just remember this property for a while. So if we have two parallel lines, we can arrange the following picture. So those are vertically opposite. So that's one also equal because of the parallel sides. So parallel lines and the second line. And so if you consider that angle, let's say this alpha, so this is 180 minus alpha is adjacent. Okay, so we have alpha here, that's 180 minus alpha, that's the quick reminding, and again that's vertically opposite angles. All right, so it's based on that, and now using similar triangles we can set up the proportions for their sides. Okay, so we have ZB1 is 1, so that's in a small triangle. So I just simply establish the ratio for size. So ZB1 is small in a small triangle relates to this corresponding side in the big one. So ZW, that's the first ratio, and this ratio will be equivalent to, again, the side in small. Sorry, X is too early, so generally A1, B1, and it relates to VW. Okay, so that's how it works. Now, actually, you just need to remember, if you start from the elements in small triangle, you need to have it in numerators on both sides. So that means it's here, okay? And the same, but for the big triangle, but corresponding sides should be in denominator. That's the basic rule of similar triangles and their features. Okay, so instead of ZB1 we put 1 because we know that it relates to ZW. So ZW is the total of 1 and x plus 1 together, so we'll get x plus 2. So 1 and x plus 1 together. And next, A1, B1, that's x, 2, x plus 4. Okay, now we have fractional equation, how to resolve it. We're just doing the crisscross multiplication, so we're doing that. Okay, so from here we can establish x plus 4 times 1, so that means x plus 4 is not changed, and x times x plus 2. So that's our proportion that was resolved. Okay, so x plus 4, and then we expand the brackets, so x squared plus 2x. From where we can set up x squared plus 2x, and we transfer all x plus 4 to the right side. So we've got x plus 2x minus x minus 4. Then we simplify to have quadratic equation in standard form. So we add x minus 4. Okay, 2x minus x simply lead us to x squared plus x minus 4. And now what we're going to do, we're going to use quadratic formula because I've estimated discriminant. And if you work out discriminant, so that's quadratic equation in general form. And what I see that discriminant, which is b squared minus 4ac, it's sort of awkward number because you cannot have the square root of this. Let's see. So b is 1, right? C is negative 4, so we've got 1 b squared minus 4 times negative 4, so we've got plus 4 times 4 is 16. So a literally says 1. So we've got 17, and that's what it said. Because right now you're going to take the square root of 17 of the discriminant according to the formula for finding solutions. Okay, so over 2a. So that's why x1 is simply, let's see, it's negative 1 plus minus square root of 17 over 2. That's two solutions. And apparently seeing that it would take with minus, so minus 1 minus square root of 17, it's negative, so side cannot be negative. In this case, we only use the positive solution, so the final solution for x is square root, so minus 1 plus square root of 17 and over 2. That's the only solution, okay? So we are supposed to find x, we found it. Okay, that was solution for the problem 3. Okay, so let's move next. Wow. So what we have here, let's see, 2 flagpoles are 10 meters high. Okay, so 2 flagpoles, they're here. Okay, that's flagpoles. All right, the flagpole. Okay, so 10 meters high and 50 meters apart. So that's the total distance between them. They separate by 50 meters. So strings supporting the flagpoles, so strings over there, as I understand. Yeah, and they are connected to a nail. So here is the nail on the ground at X as illustrated here. All right, so that's the nail. So they strings connected here somewhere. And if the strings are perpendicular to each other, means they arrange 90 degrees angle, what is here. So you need to find the distance between the nail and the nearer flagpole. Okay, so maybe it's not a scale, so we're not sure which flagpole is the nearest one to the point X. So anyway, we need to figure out. So what I recommend, so what to do, we can set up some variables or input variables. So if we put X here as the distance from this flagpoles to that one, so it's not a big one, but it's small x. So I put, okay, the letter small x. That's the distance to that flagpole. So we know apparently that that distance to another flagpole is simply 15 minus x, right? The whole distance, and we subtract this segment, okay? This segment. We subtract it from the 15. So that's why we've got 15 minus x. Of course, we can use another variable, like say y, and then express y through 15 minus x, but you know, if you can't do it from scratch, just do it. Okay, so now we have two triangles, both with a height of 10. So we also arrange the angle 90 degrees between them. Okay, so cool. What we're gonna do right now, we gonna use, let's see what we can use. Then we have a distance. We can probably establish the, yeah. So we can figure out Pythagoras theorem for each triangle. Let's say this is triangle 1 and this is triangle 2. So what we're gonna do, we can establish their hypotenuse. So let's express hypotenuse in each triangle. So let's say this is hyp 2, which is here, and this is hyp 1. So what it gives us? It gives us definitely the hypotenuse for each one. All right. Why? Because next step, I just connect these two tips of flagpoles with a parallel line, which is actually 50 meters, because so the same heights, right, for each flagpoles. If I connect with a parallel line to the ground, which is 50 meters also, I can establish the third Pythagoras for that triangle, and I connect hypotenuse 2 and hypotenuse 1 with this hypotenuse, which is 15. All right, so let's do it consequently. So first, hypotenuse 1 from the first small triangle. So it's x squared plus 10 squared and square root. So that's why I just use square of hypotenuse 1, and that becomes x squared plus 10 squared. So what about hypotenuse 2? Let's see. Hypotenuse 2 squared is simply 10 squared, again, and you need to add 15 minus x, total is squared, because this is that leg. Okay, so what if you add the left hand side of the equations? If you add them up, you'll get exactly what I'm saying before. You'll get this hypotenuse actually for the big triangle, which is here, because it's right angle. Okay, so what we're gonna do, we can add them up, and left hand side of the equation becomes 15. So if you add them up, you'll get 15 squared in total because of Pythagoras for that triangle. Okay, so that's why it's 15. So 15 squared actually equal to x squared plus, I just arrange first all expressions that contains x's, and then 10 squared and 10 squared, I'll get 200 in total, right? Okay, so I've got that equation, and now we simply need to solve that. Okay, so I'll just transfer it here and simultaneously simplify it. So 15 squared is 225. 225. Next, I've got x squared. Then I expand the brackets here. So again, 225. That's formula, right? A minus b squared. So 225 minus 2 times 15 is 30x. And I add up x squared in the end, and plus 200. So make sure you remember how it works, how the formula works. I just remind almost in every single video how it works, in order for you guys to have more easy stuff, and by the way, to memorize that. So a squared minus 2ab and plus b squared, that's what exactly I used here. Sorry, not there, but b squared, I use it here. Yes, so when I expand in that brackets. Okay, so let's see. So what I can do, I can see that 225 on both sides. So if I transfer, that will be literally cancelled. So I consider the right hand side of the equation. So I can say that x squared and x squared, I'll get 2x squared, then minus 30x, and then I add 200. All right, so let's see, equals 0. So what I'm going to say that I'm just going to divide by 2. Let's see what I have, x squared, then minus 15x and plus 100. That's what I've got. Okay, so what I see right now, this equation doesn't have any solutions. Okay, if you try to figure out for x, you simply state that discriminant, which is b squared minus 4ac, and you'll get 15 squared minus 4 times 100, so which is 400, and you'll get 225 minus 400, which is negative. So what it means? No solutions. No solutions. Within a given task, within a given conditions, we're not supposed to solve that. All right? So in other words, there are no combinations for x that might give us a solution for that task. So yeah, that's weird a little bit. However, this is impossible to have, okay? So it looks like maybe the distance instead of 15 should be more. So they need to be split apart more than 15, and that's how it should work. Okay, so maybe next time I'll just rearrange that. I'll use the same logic in the next video, and I'll try to maybe set up, instead of 15 apart, maybe distance more than 15, okay? That will allow us to find solutions, all right? So hope you enjoyed. That was demonstration that sometimes you might not have solutions, and that means sometimes your quadratic equations might not have solutions, which actually discriminant is negative, okay? So hope you enjoy, guys. Don't forget to subscribe, and we move next.